So I do a lot of this. Some work that I have done along these lines includes a project that I call Whale Fakes, which is one of the very first ones that I ever did. I'm very proud of. And it's a Twitter bot that just is tweeting ridiculous things generated by a language model that was fine-tuned on my favorite Twitter account, which is called A Whale Fact. And it comes up with this brilliant stuff like, yeah, do you realize that at least one whale is on drugs? And really, I think this is what GPT was really meant for. It also has some really great things like there are no laws that say a humpback whale cannot drive, which is a true fact. So it does really great work, is what I'm saying. And basically, what I wanted to show you is that not all things that you end up creating are going to be groundbreaking research, and that is totally okay. You can just do things because it is quote unquote art, or maybe just a lot of fun. And honestly, the world kind of needs more fun right now. So not everything you do has to be serious. And I also am a big believer that all the very best learning that you could possibly do comes from just building things. I think it's really easy to fall into a trap where you read papers and can kind of talk about things at a high level, but the way to level up the most is just to start building things, put them on the internet, and you will learn so much more from that process. And so I really encourage that kind of thing. And to do so, I propose that we contribute to the world in what I call units of fun. And that is what this entire talk is about. So I have some ideas for you to do so. And if you're like, well, Helen, why are you somebody to lecture us on fun? Why would ever you be qualified? Well, I'm telling you, I'm like really good at it. One thing I built is this Wolfram Beta, which is kind of like if Wolfram Alpha were powered by a neural net, but it really wasn't very good. And so I took a neural net and trained it on the DeepMind mathematics data set. And it turns out they're shit at math, but that's okay. It ended up being hilarious. Also, a project that I built for a hackathon with a friend earlier this year is called Caleb, where we trained a language model to generate stock advice. It's really terrible at it, and I highly would not recommend taking any of the advice that comes out of this. Also, we had to replace it with a random number generator because it was really expensive to serve a transformer as a joke, and none of us wanted to pay for serving infrastructure, but great experience. Another thing I built is Fake Trump, which is just president generated or tweets generated to sound like the president. And really, I think it says more about the president that it is so difficult to discern between what he says and what an AI model generates, but that's neither here nor there. And also worked on a side project for a while called Unnecessary AI that is just all about showcasing stupid stuff that nobody ever really asked for or needed, but is great fun. And so I highly encourage this kind of thing. And so what I realized that it's just really hard to get started because how do you choose an idea? So here's some free ones. One of them that I came up with was scraping fortune cookies and then generating more fortunes. And there's a bunch of fortune cookies on the internet already. I don't know what people are using these corpuses for. They're basically made so you could build more crappy AI projects on top of them. Like, I don't know what else you could possibly be using a fortune cookie corpus for, if not that. It was pretty much made for it. GPT-2 is also extraordinarily good at saying stupid, random stuff, just like fortune cookies. So this is just asking to be created. Oh yeah, this is some examples of the corpuses. You'd be shocked at how many there are. I don't understand why there's so many. Another idea that I had for you was podcast generation, because you know how podcasts already have transcripts out on the web most of the time in plain text, which means you could just collect up a whole bunch of them. And because it's so easy to fine tune a language model these days, you could just get them to generate more podcasts. And then once you do that, I think that you should record them with a friend and then just put them on the internet, and they would probably be really entertaining. I would probably listen to one, maybe not more than one, but I think one would be really funny. So you should also build this. Um, Another thing that you could do is, because TikTok is so hot right now and there's all these memes about what kind of TikTok personality you are, you could just categorize these images into what kind of TikTok personality you are. And I think that would also be really easy to do with machine learning with questionable degrees of accuracy, but that's not what this is about anyway. Another thing you can do while you're busy scraping TikTok data, apparently there's a bunch of TikTok scrapers. God knows what people are doing with those. But anyway, if you want to scrape TikTok, what you should do is train again on all that media. People train GANs on the wildest things, by the way. So you might as well just do that and, I don't know, put them up and go maybe minorly TikTok famous with an extremely niche 5 people. So that's an option. Another thing you could do is scrape Board Game Geek for all of their game descriptions. And then you could also just generate a new game and then actually make your friends play it. And then just go with whatever the instructions say, kind of like True American in that show New Girl, if you've ever seen it, where the instructions are completely incoherent, but the game is so funny. So I think you should just do this. Also, StyleGAN for world maps, which is just like if an AI were to come up with more new maps about what the world should look like, you could also do that because there's a bunch of map images that are out there. So it's really easy to get a lot of data. Another thing you could do, and this is one of my favorites, is you could take CycleGAN and you could make one of the domains Ryan Gosling photos. And then you could just have any image get transitioned into an image of Ryan Gosling, and I call it Gosling GAN. And this is just like a thing begging to be made, and I'm shocked no one has made it yet. Though there was that one AI the other week that someone found that would upsample your images to have Ryan Gosling in the window totally by accident, which is like kind of like this, I guess. But anyway, there's just so much training data out there for this, so I think you should do it. Also, you could really, as it turns out, just do anything with these. There's this collab that will get you started where they turn dogs into spaceships, but you could sub dogs and spaceships with pretty much anything. My recommendation is Ryan Gosling photos. There were also a couple of ideas here that I had that didn't make the cut because they were bad. Human to alien GAN sounds like it'd be terrifying, and you'd probably get scars from the training process because I imagine the intermediate photos would be really scary. And then style GAN for fruit, there's a bunch of weird fruit out there already. I don't even know that you need style GAN for this. Anyway, what I think you should do, and I hope you take away from this talk, is that you should create things and just put them on the internet because it is great for learning. And also, one time somebody tried to recruit me off of them. So if you're looking for a job, that's also great. Also, I think you should submit them to this conference called SIGBOVIC. And the whole goal of this SIGBOVIC conference is the manifestation of, or joke manifestations of joke ideas, or serious manifestations of joke ideas. So if you build any of these things, they will fit right in there. So it's just asking to be made. So I hope you build one of these things. And if you do, please let me know. I'd be really stoked to see it. And basically what I think is that everybody talks about how AI is the future. And if it is the future, I think it should be fun. That's all I got. Thank you for listening. Please tell me if you build any of these things.
Thanks a lot, Helen. I hope people here will be building some of your ideas.
I hope so
and
too.
We get to see them at a future is event where everyone can present those ideas, present those projects. So next we have Josh. Hello, Josh.
Hello, how's it going? I'll just share my screen. Let's see. Okay, can you see a presentation or can you see a textbook?
A presentation.
Okay, cool. So my talk is going to be nowhere near as fun as Helen's, but you can kind of think of it just as an extension of her board game generator idea. So let's go with that. So just to put this in sort of a historical context, If anyone's not familiar with the terms connectionism and symbolism, or symbolism is also sometimes called computationalism, I'd highly recommend checking one of these articles out. But to vastly oversimplify things, the basic idea is that in connectionism, we think of intelligence in the mind as a neural network. And then in the symbolic approach, we think of it as a computer, like a Turing machine that executes formal logic. So I've been playing around with GPT-3 a lot these days, and it has sort of a general reputation observation of it being not very good at math, or unexpectedly not good at math. So if you give it like actual symbolic formula and whatnot, it has a lot of problems, especially with big numbers. But there's this weird hack where if you put like a comma instead of no spacing, then that can solve a lot of problems. So there's a great article by Gwern where he makes a pretty convincing argument that this might just be sort of an implementation level bug. So they're using what's called byte pair encoding, and that sort of is lossy at the level of character encoding. So it could be the case that when you have symbolic notation, GPT-3 just isn't really able to deal with that. However, that doesn't really explain why GPT-3 is also not able to deal with lexical numbers. So lexical numbers, just like if you write out the number 20 using letters. So you'll see here, if we give it a few training examples to do some few shot math, it's able to get the first one, and then this one is wrong. So here is another example where it's being sort of a little bit more linguistic, or more lexical. So now instead of using variables or anything, we're just talking about something very concrete like hens. And here, so at the top, you'll see some of the training examples, and then these are GPT-3's attempts. So obviously the language itself is very plausible, but the numbers that it gets are wrong. So, okay, what's the big deal? Why can't we just give GPT-3 a calculator and call it a day? So the problem is that language is embedded in mathematical relations and vice versa. So like here, even if you do have a calculator, you still need to know what the right numbers to put in, all the operations and all that. There is a really fantastic article written about GPT-2, but a lot of the same criticisms still apply to GPT-3. And one of the quotes from that is, anything that looks like genuine understanding in GPT-2 is an illusion. So it's by Gary Marcus. It's a really good article. I recommend it. But while I think he's right, I completely disagree with his rationale. And I won't get into that. I have a whole blog post on that. But what I think is really important to focus on when thinking about sort of what GPT-3 actually is in relation to intelligence. So I don't know if anyone is familiar with Daniel Kahneman's dual processing theory of mind. So he breaks things down into system 1 and system 2, which are just like a rough dichotomy. And in a sense, this kind of maps on to the whole computationalism versus connectionism debate as well. So what we're seeing with GPT-3 is a lot of intuitive and instinctive and sort of emotional laden things. So it's very good at quickly generating stuff based on associative relationships, but it's completely missing all of the formal, well thought out, rational, logical systems. And so the original Turing test, actually a fun trivia fact, it actually does contain a mathematical question, but it's not really testing that sort of underlying formal systematic representation of the world. So what's great about Dungeons and Dragons is, even though it's completely embedded in natural language and it's all about creativity and generativity, it also comes with a very sort of constrained and highly complex rule book. So there's rules, there's norms, there's entities, etc. So what I did is I took an excerpt from a D&D 2nd edition and I plugged it into GPT-3 just to see what it came up with. So these results are kind of cherry picked, but you'll see GPT-3 is able to to generate a lot of just like super creative stuff. So at the very least, you could see this being used to give all sorts of like really interesting, provocative suggestions to a dungeon master. But what I was interested in is GPT-3 really actually able to fully emulate a dungeon master? And I would go with no. So here's another example. Keeping in mind, this hasn't been fine-tuned, so the results are kind of meaningless. But I think the core idea still applies. Anyway, so here you'll see now there's a little bit of mathematics and rule play involved. So in the green one, you'll see GPT-3 actually was able to correctly add the 6 to the 4 to figure out that it was 10 hit points. But you might wonder if we then asked a follow-up question about how many hit points Fighter 2 has, whether it would actually be consistent. And then in the orange, you'll see it kind of completely misunderstanding how initiative works. So initiative is to figure out who goes first. So everyone is rolling initiative in this scenario, but the points don't really matter. So it's not actually connecting that. And so what I am half jokingly proposing is to the next iteration of the Turing test can be the Dungeon Master test. So basically, can a group of experienced Dungeons and Dragons players reliably distinguish an AI from a real Dungeon Master? And yeah, I don't know, I think that's probably out of time, but there's a few interesting models and work going on that's actually trying to integrate the symbolic approach with the computational, or sorry, with the connectionist approach. But I think we're still a ways off.
Thanks a lot, Josh. That was really nice. And the final speaker is Aditya Yoshi, creator of GPT-3examples.com.
So hi, I'm Aditya. I'm a machine learning engineer based in Toronto, and thanks for inviting me for this event. It's really cool to see all these people. So yeah, what I'm going to do is basically talk about GPT-3, what it is, and some of the cool examples that of applications that people have built. So I thought it would be great to collect all these examples and put it on a website. So you can check out GPT-3examples.com, where I've compiled a list of these applications. So, and finally, I'll talk about what excites me about GPT-3 and what I see happen in the future. So GPT-3 is basically an extremely large language model. And what a language model does is that given some previous context, some sequence of tokens, it predicts the next token which has the highest probability. So essentially, the word that is predicted has the highest probability of existing given some previous context on the training data that it was trained on. So the API that OpenAI released has a very sort of simple text in, text out interface. So all you do is that you provide it a sequence of tokens, and it basically completes them. So for example, if you wanted GPT-3 to learn addition, you would say, well, what's 1 + 1, and it would hopefully say 2. And the cool thing about GPT-3 is that it can basically learn to perform tasks in like very diverse number of domains. So I saw examples from ranging in finance to converting English text to SQL queries, from English to Latex, and so on. So I'll just show you some of these examples in the next slide. And the cool thing about GPT-3 is that it was all, it was basically trained once on 300 billion tokens. And basically, okay, I'll just move on to the next slide. So what we see here is that an application that converts English text into JSX components. So as you can see here, he's basically described a button. So he says, give me a button that looks like a watermelon. So GPT-3 basically converted this into this JavaScript component, and this is what's rendered. So it's really cool that this could be done basically with a few examples. So what you need to do is just provide around 3 to 5 examples, and GPT learns to essentially get context about that particular application, and it adapts to that application. So if you see the next example, yeah. So this is an example of text to LaTeX. So it's often very annoying to write LaTeX equations, and I think this one is a very cool example where Shreya Shankar has essentially trained GPT-3 to convert English tokens to sort of render LaTeX equations. This was again done using around 3 to 5 examples. So you can, she's made the code open source. You can see, I don't have the GitHub link right now, but basically it's around 3 to 5 examples and it learns to extrapolate. This is another cool example where you have some exploratory data analysis. So this is all associated with one particular data set. What Ken has done here is that he's basically described in English the kind of plots that he wanted. So he says, display a line plot showing the maximum temperature on the y-axis separated by the weather type. So the weather type is essentially like a categorical variable, and you can see different lines for different weather types plotted here. So GPT learned how to parse that information, aggregate the data, and then plot this information into an SVG file. And I've seen some cool examples with Plotly as well. So I think Plotly created some bar charts and pie charts that were directly generated from text. And this is an example that I saw this morning. It's made by this famous indie hacker called Peter Levels. It's basically, he has GPT-3 spit out random examples of startups, and he wants people to vote on some good ideas, essentially to search the startup space and find out interesting ideas. I mean, I don't think this will actually work. It's just sort of cool example of what it can do. And there are some pretty interesting ideas here as well. And finally, I'll just talk a bit about what excites me about this. So firstly, I think this can be used to create new data sets. So what currently exists in the world, I think a large amount of information is present in the form of unstructured data sets. For this may be in like non-technical fields like law or medicine. So if you could convert these sort of unstructured data sets into a neat tabular data set, it could enable a lot of, for example, scientific research that's carried out. So just as an example, in the Indian context, there exists about a few million documents of law data that are publicly available. So if you could convert this into a neat tabular form, you could do a lot of scientific studies on that. For example, you could find out if judges are susceptible to some specific biases. This is just like one example of many possible things that could happen. So another, the second thing is that it can be sort of used as a baseline model for researchers and engineers. So you wouldn't have to train a model from scratch. What you could essentially do is use GPT-3 as a building block because it's already been trained to perform very well on different tasks. So you could just use this and build your custom model that does something specific very well. And as we've already seen really cool examples, people building. I think there's already a couple of startups that are using GPT-3 as a backend. So we've already seen a bunch of like useful stuff come out of this. And lastly, I don't think we have seen a cap on the performance. So right now, people are just throwing more compute at the problem, and language models are still tending to perform better the more compute we throw at it. So GPT-3 has around 175 billion parameters, which is about 100x improvement from GPT-2, which had about 1.75 billion parameters. So I'm just curious to see what happens when you 10x or 100x this number. Like what happens when you have 1 trillion parameters. And I'm not speaking in terms of an AGI perspective. I just think that even though, I mean, we've already seen so many cool examples. So what happens when you just put in more compute power? We haven't reached the point of diminishing returns. So I'm just interested to see what happens. All right, that's it. And I hope you found this helpful. I'm fairly active on Twitter, so feel free to follow me.
Thanks a lot, Aditya. And thanks to all our speakers for taking their time and giving these talks. I hope you found them all inspirational and provided you with a lot of food for thought.